This is the second part of the first lecture, and now we will have a look at our very first optimization problem, which is the cardinality version of vertex cover. In this problem, we are given a graph, and a graph for us is a tuple of a vertex set and an edge set. Vertices are represented as points, and edges are segments that connect two vertices with each other. What we want to find now is a minimum vertex cover, and that means we want to find a minimum vertex set, so a subset of all the vertices, such that every edge is covered. So for every edge that we have here, like this segment, one of the two end vertices has to be in our cover. The first question I have for you now is, can you find a vertex cover for this given graph? Well, let's try to do it together. We can just arbitrarily pick one vertex, and this vertex now covers these two edges. Now we just pick another vertex like this one. This covers these two edges. We pick the next one that covers this edge. And we just keep picking vertices until all our edges are covered. And now we have found a vertex cover because for every edge, one of its endpoints is in the vertex cover. So we have found one of size 1, 2, 3, 4, 5, 6, 7. Now, of course, the next question is this actually a minimum vertex cover? Now, is there another vertex cover with a smaller number of vertices? This is also not so hard to find. We can just have a look at some of these edges. For example, this edge here is covered by the brown and by the orange vertex, but the brown vertex does not cover anything else. Also, these two edges are covered by the red one, but they are also covered by blue and green. So we don't need the red one, we can just remove it. We can remove the brown, and we can also remove the pink here. The pink one is covered by the green vertex, and this one is covered by the purple. And now we have found a smaller vertex cover. This now only has size 4. We have 4 vertices. And actually, for this graph, this is also the optimum. There's no vertex cover with a smaller number of vertices. Now you can think, how do I prove that there is not a smaller one? And to do that, let's just have a look at 4 edges. We can take this edge here. Now this tells us one of these two vertices has to be in the cover. Take this edge here. It tells us one of these two has to be in the cover. Take this one here. That says one of these two has to be in the cover. And this edge tells us that one of these two has to be in the cover. That means that for each of these edges, we must have one vertex in the cover, so we must have at least 4. That means this actually is our optimum solution. The problem is, in general, it's MP hard to find the optimal solution here, so we have to go and find an approximation algorithm. And the approximation algorithm might not find the solution with 4 vertices, but maybe it finds one with 5. And this is the basic idea behind approximations. The optimal solution has 4 vertices, and we have an algorithm that finds one with 5. So that gives us a 5/4 approximation for the optimal solution.